Hello everyone. So in this lesson we are going to be working with multivalent metals. By the end of it, you should be able to create chemical names with compounds involving multivalent metals, and you should be able to write their chemical formulas. Now, make sure to have watched my ionic compounds video before moving on to this video, because there's a lot of background information that you are going to need there as well. So let's get into it. What does multivalent even mean? Let's break down the word. So multi, meaning sort of more than one, and valent, referring to the valence electrons, or the valence of atoms. And so these are metals that can have more than one valence. Let's take a look at our periodic table. Yesterday we were working with a lot of the elements from over here in terms of metals. And you will notice they have one valence. So there's a plus, there's a 2 plus, and that goes down the whole column. If we take a look at some of these metals hanging out in the middle, for example, titanium, you can see that it is split in half. So this is titanium 4 plus, and this is titanium 3 plus. And there's a number of metals that have that property. Things like copper, nickel, cobalt, iron. And so these are all multivalent metals. So I went in and highlighted some of them. But you can see that depending on what the atom is, the valences are different. So copper can have copper 2 plus or copper plus. Nickel can be nickel 2 plus or nickel 3 plus. It just depends on the metal. So you're going to be using this table anytime that you see a metal that might be multivalent. Okay, so let's start with writing the formula because it's easier. Now, what you'll see here is the name of the compound, copper 2 oxide. The type of copper it is indicated using Roman numerals. So our Roman numerals are 1, 2, 3, 4, 5, and 6. And you will probably see nothing higher than 6. But those are our Roman numerals. And so this is telling us it is copper 2 oxide. Over here we have copper 1 oxide. So we have both possibilities of valences for our copper down here. If I'm asking you to write the formula, you're going to do it very similarly to how you did it in the past. However, this time the name gives you some added information. And I'll show you what I mean by that in a sec. So copper, the symbol for copper is Cu, and oxide, the symbol for oxygen is O. And as always, if you're not positive about what the symbol is, I encourage you to go look at the periodic table. Then I am going to write down the charges. So oxygen, if we go take a look at our happy little periodic table, oxygen is going to be over here. Oxygen is 2 minus. And copper, oh wow, copper is a multivalent metal. It can be 2 plus or plus. And here's where that additional information comes into play. So, like I said, oxygen is going to be 2 minus, and copper can be plus 1 or plus 2. Except the name tells us which one it is. So it's going to be 2 plus. So what I can do now is my very technical little swapsies. or know that these charges cancel out to equal 0. And so 2 and 2 will leave us with copper oxide, copper 2 oxide. And so that's our final formula. We don't bother writing down those 2's because, well, it's redundant. It's a 1-to-1 ratio in terms of charges. Over here, we're going to do the exact same thing. Copper is still Cu, oxygen is still O, oxygen is still 2-, and copper is, well, copper can be +1 or +2. But our name tells us which one it is, so it's going to be +1. If we do our little swapsies in order to figure out, to balance the charges in this compound, that's going to leave us with copper 2 oxide. 2 indicating the number of copper, and this is blank indicating the number of oxygen, which is 1. So just as a refresher, if you need it, these are the charges, and these numbers indicate, well, the number of ions or atoms that we have. Okay, so what I have done is put a sample problem down here. What I encourage you to now do is to pause the video and try to find the formula on your own. So seriously, give it a try. Anyhow, once you're done, check your answer with mine, and I'm going to go ahead and write it out. So cobalt, I know, is right here, and its symbol is going to be CO. And chlorine, I know, is over here, and its symbol is going to be Cl. Chlorine is -1, and cobalt, this name is telling me that it's going to be cobalt 2. So cobalt is going to be 2 positive. And if I do a little swapsies of charges to find out the numbers that I need, I'm going to have 1 cobalt and 2 chlorine. And so this should be your final answer. Okay, let's move on to naming multivalent metals. We're going to start with a familiar example. So we're going to start with COCl2. Now, you just did this problem. So from experience, we know that this is cobalt 2 chloride. Let's break down how we get from one to the other. The first thing you're going to want to do is rewrite the metal. So in this case, the metal is cobalt. And, you've recognized, well done, that this is going to be a multivalent metal. So you're going to just put those brackets in and save that space for later. We don't know which cobalt it is. I mean, we do because we just did the problem, but technically, or usually, you'd have to figure it out. And then you are going to write down the nonmetal and make sure to have that suffix IDE. So at this point in time, we are pretty close to being up here. However, cobalt can have a charge of +2 or +3. And I need to figure out which one it is going to be based on my formula. So right now we have cobalt, chlorine, and there's 2 chlorines. So chlorine has a charge of -1. However, there are 2 chlorines. So together, 2 chlorines times a charge of -1, 2 times -1 is equal to a total charge of -2. And cobalt can be either +2 or +3. Altogether, we want these charges to cancel out or equal 0. So depending on the way you think of it, we want them to cancel out. Now, If we were to look at +3 and -2, that would indicate that there is an extra positive. So it can't be that one. It cannot be +3, leaving us with +2. And so now that I've identified which cobalt it is, because +2 cancels out with -2, it's neutral, it has a charge of 0, then I will go ahead and add in my Roman numerals. Okay, here's another example. Here's a formula, and from recognizing it, I know that this is copper, and hopefully you have recognized that it is a multivalent metal. So when writing down the name, you're going to start with rewriting the metal. I've recognized that it's a multivalent, so I'm gonna leave my brackets there until I come back to them. And then I'm going to write the non-metal, making sure to add that suffix "ide", nitride. And we have to figure out what that Roman numeral is going to be. So nitrogen can have a charge of -3, or that will be its charge. Copper can be +2 or +1. We don't know which one it is. But again, we have to make them cancel out. So hopefully you can see that there is one nitrogen. We know this because there's no subscript down here. So because there's one nitrogen, its charge is going to be -3. Over here with copper, it can be +2 or +1. However, there are 3 coppers. So if we have 3 coppers, and let's say it was copper 2, then our charge over here would be +6, because 2 times 3 is 6. And that does not work with our nitrogen. So I know that it can't be that copper, meaning it has to be copper 1, which makes sense because 1 times 3 is +3, which will cancel out the -3. So I'm going to go ahead and add in my Roman numeral, and that is its final name. Okay, we're going to do one last problem together, because this one can be a little bit tricky. So over here, we have iron, and I've recognized that iron is a multivalent metal, so I'm going to leave my brackets, and I'm going to put the non-metal, which is nitrogen, and making sure to put that IDE suffix. So we have iron, something, nitride. Nitrogen, same as last time, is going to be -3. The iron can be +2 or +3. So we need to cancel these charges out, sorry. In order to do that, you have to take into account the charge as well as the number of ions down here. So the nitrogen is going to have 2 nitrogens. So we're going to go 2 nitrogens times a charge of -3. And so, of course, 2 times -3 is going to be -6. So that's what we're going to be trying to cancel out. Over here, we have 2 options. Let's say we know that there are 3 iron. So there are 3 iron. And one possibility is to do times 2. So times +2. So 3 times 2 is going to be 6. That's looking pretty good because +6 cancels out with -6. If you want to double, triple check, we can always do that. So we'll do the same thing, but this time with the other charge. So 3 iron times a positive charge of 3 is going to be, 9, because 3 times 3 is 9. So that doesn't work at all, which leaves us having iron 2 as our final answer. Okay, what we have here is a sample problem for you to try. Again, pause the video, give it a try, and check your answers off of mine. And I'm going to go ahead and solve it for you to check your answers off of. Hopefully you paused your video. We have nickel, and I'm going to go ahead and write that down. I know that it's a multivalent, so I'm going to leave my space for that. And we have bromide. Bromine is going to have a charge of -1, and nickel can have a charge of 2+ or 3+. Now, I see that there are 3 bromine, so in total it's going to have a charge of -3, and there's only 1 nickel, therefore it has to be +3. And that's your final answer. So that is it on naming and writing formula for multivalent metals. Make sure to practice this, and good luck.